We are almost 20. If the other keep joining, and then we can start. I'll start sharing the screen. Am I audible and can you see my screen? Okay, I think I should start just to explain some few things and then we go. Can you hear me correctly? Hello, can you hear me?
Yes, sir.
Okay, okay. How much? I think we should start slowly and then because there's still people still joining and then I'll start slowly. In this session, what we're trying to do is from everything that we learned in the first session, we are trying to see how we can basically we need to get our hands on the algorithms to see how they work and we can have a first trial of them and explains so we can see how from the mimicking the human from us trying to predict something and then uh, the machine trying to predict it. So we'll be having at least three demos. Well, the first one will be DBScan. Uh, the DBScan, which will be trying to, this is, okay, we'll be trying to, just since it's DBScan, I'll explain what DBScan is, but we'll be trying just to, this will be dealing with unlabeled data, that one I showed in the PPT. We'll be seeing how do we deal with this unlabeled data, and then we'll try to check to predict the house prices. Here, we will see the data set, how it is, and then by looking it, we can see we as humans, as persons, how can we be able to predict the house prices, and then we can try to predict the air pollution. So we'll be dealing with these three tasks, and then I'll be explaining the code. We'll also see the data sets. So I think we should start with which one? The simple one. Let's start with the DBScan. The DBScan data set which are used in DBScan. Let me open it. Oh, first of all, I'm using a Jupyter Notebook. As you can see, the label here is Jupyter. So to be able to run Jupyter, you need to install it. After installing it, you need to run in the terminal, just write Jupyter Notebook, and then it will open in the localhost like this, and then inside it will have your works. So I don't know, but they will be given prior instruction on how to do your assignment. But for this one, I'll just be using Jupyter Notebook. And the coding, Python coding, and the dataset, they're all in the same file, in the same directory, so it can be able to see. So with DBScan, the dataset which will be used, it will be this A1, case1 underscore 91.txt, and this R15 text. So let's open DBScan first. In DBScan, basically what we are trying to do, we are using unlabeled data. We said unlabeled data. With unlabeled data, what we'll be trying to do, we'll be trying to predict the pattern inside that. So let's open this case. I'll be using case 91.txt to see what inside that data set. So if we open this data set, you can see, sorry, there are people waiting in the waiting room. Can someone please accept them so they can join the session? This is the data set that we were. Okay, everyone has joined. So this is a data set that we will be trying to evaluate it. Remember, this is unlabeled data. So from this unlabeled data, there is a pattern that is within this labeled data. So using the model, the algorithm called DBSCAN, we need to be able to learn what is the pattern inside this data. So this is the first data set. The second data set is A1, which is also having two columns. If you highlight this, you'll see it's having two columns. It's two columns of numbers, two series, continued, two columns of numbers. And then for R15, it's also having numbers. So basically, we are trying to predict, or we're not trying to, we're trying to see what pattern exists in these three data sets, R15, A1, and case 91. So I'll go back to DBSCAN. DBSCAN is an algorithm which can be used to detect patterns inside the data set, whereby it's work by checking which pattern are close, which pattern are neighbor with each other. So since we're just in the demo directly, I'll just explain the two main parameter required for DBSCAN to work. The most important parameter in order to be able to say which parameters, which points or which patterns are close in the same data set, we need to have epsilon, and then we need to have minimum points. So this is the variable for minimum points, which I highlight here. And then we need to have epsilon. We said DBSCAN works by checking which points are close to each other. So epsilon is epsilon. Let me highlight it. I'll be highlighting it. Do you see my cursor? Can you be able to see my cursor, or should I be highlighting the text that I'm insisting on? Hello?
Yes,
Can
sir.
you,
Yes, sir, we can see.
you're seeing my cursor. So if I point using my cursor, it will be enough, right?
Yes, sir.
Okay. So this epsilon, we have two important factors in DBSCAN to be able to classify, to be able to detect the, how do we say, to detect the pattern inside data set using DBSCAN. The one is epsilon and another one is mean point. Mean point is how much, what are the minimum points which when they are close together in a certain distance, we will be saying these points are close together. They are forming a pattern. So epsilon is the distance whereby the hello. Sorry for the inconvenience. My network check. You can see my screen now and you can hear me now, right?
Yes, sir.
Okay, okay. The network should be here. So the 2 points, epsilon and mean point. What the DB scan is trying to do is trying to see which minimum point can we be able to detect, which will be using them as, which will be from a distance, which is epsilon, we will be grouping them as they are forming a pattern. That's the thing that DB scan is really trying to do. So when we start with the coding, when we start with the coding, we first how to be able to tell the minimum point. There is something we call rule of thumb. Like if you have a data set, for example, this R15, it's the data set, it has 2 columns. So if your data set has 2 columns, your minimum point, you take those columns, you add it by 1, then that's why in the min point, we had 3. So same way for the epsilon, to be able to tell the epsilon, we'll be needing to write some, we'll need to read the data set. From reading the data set, we need to draw this k distance graph. And then from that k distance graph, we need to see where that the data is forming an elbow. This k distance graph is just showing how the data how the line start forming an elbow. An elbow is the case when the linearity of the line start changing dramatically. That we call an elbow. So we can see here it's around in 10, it's around in 20, and around 30. So we can be from this k distance graph, we can be able to tell what our epsilon would be. The mean point, we ruled from the rule of thumb, like the mean point is supposed to be 3. So basically what we do is basically read from the file. This is the function for reading the file, the method for reading the file, where we'll be passing the file here, .text, and then we assign the minimum points to be 3. And then from there, we're starting finding the neighbors feeds and distance and indexes, so that we can go on drawing the k distance graph. So we can see these 2 lines are getting the neighbor feeds from the data set. It's getting neighbor feed, and then the neighbor feeds is getting distance and indexes, which are used to draw the k distance graph. And then from these just points, we get the distance, and then we sort it, and then yes, we just get the distance, we sort it, and then we go on plotting the k graph. Yes. And then from the k graph, remember, from this k graph where it's forming an elbow, that's when we will be getting our epsilon, this value here for written epsilon. So from there, if we run this, it will be generating this k graph. So our epsilon can be anywhere from 10 to 40, depending on how we'll be seeing our database, because it does not give you an exact number. It's just a rule that when the k graph start forming an elbow, that's your epsilon will be, which are the 2 parameters required by DBScan. So now we already have the 2 points. We have the epsilon, we have the mean point. We need to go on writing the DBScan. This is just function which will be used in DBScan, whereby basically what we'll be doing, we'll be starting with 1 point from the data set, which is when we start with that point, let me find the function which actually, let me start with DBScan here. We'll be entering set of points and then epsilon and then minimum point. So this is the actual function which does DBScan. No, it's end up, yes, I'm still here. End up with returning classification. So the two parameters, epsilon and minimum points, will be providing. And then we'll be providing set of points. Let me find where we call the dbscan. One time, it will be dbscan, okay. Here, it will be reading points from file, the function we created, which will be reading it will be reading the, what do we call again? The set of points. Each point will be as a starting point, and then from that starting point, we'll be calculating how many points are close to that point, whereby they reach a minimum point of 3, or we change it to 5. Will they reach a minimum point of 5, and then they have the epsilon, which we already created. And then if that point meet all these two criteria, we will be grouping those points in as they are in the same pattern. That is the classification, or that is the clustering that will be forming. And then we'll be creating the labels and the colors. Let me just show the image here so we can be able to understand each other. This is the clustering of the dataset 91.txt class. So basically what happened is, for each point, let me open that dataset one time. Here's 91. For each point, let's assume this one, we are reading the first one, the first row. What it will be done, it will be checked. This point has X and Y. We are seeing column Y here, and then we are seeing X on the other side. So what it will be done, for each point, it will be calculated how many minimum points which are close to this within a given epsilon, which we have already defined. The epsilon is 30. This is the distance based on the K graph we drawn up, and then we'll be forming which points are close to each other than other points. So if we see the points here, this color I think is orange, yeah, are different from other points which are far from these points. So same way, these points which are bluish, they are far from the points which are yellowish. So these black points, as per our codes, they are referring to noise. Like, you have a data set. Noise is when you have a data which does not conform to any pattern defined in the code. So basically, this code, what it does, it creates patterns from the data set which we have given it. So if we were to create now, this is from unlabeled data set. So if we were to create a supervised learning from this data set, if we want to label this data set now, so that we can create, we can go for supervised learning, each cluster here can be given a name, like these are yellow. So if it was, we could know anything about the data set, we'll be able to say all these will be given yellow, these will be given this color, this will be given this orange light, this will be given that color. So all these can be forming 3 classes. And these which are appearing as black, will be terming them as noise. So in the supervised learning, we will be removing the noise. So basically what it does, it took in all the data. We declared we declared the minimum points, and we declared the epsilon. So let me do one thing so we can be able to understand why do we need to calculate the epsilon point using K-graph, and why do we need to have minimum points. So if we say minimum points, sorry, let me reconnect the keyboard. Okay, I think now you can see better. If we need to change the minimum points to 3, and then the epsilon, we need to change it to 15. So what this means is we need to look for at least 3 points which are within the distance of 15. So if I go on rerunning this, you can see using a mean point of 3 and epsilon of 15, a lot of data in our data set appear as noise because there are less data which will be in a minimum point of 3 in a distance of epsilon 15 based from our K graph where it's starting forming an elbow. Let me show again. 15 will be around here. From K graph, when we are saying it starts showing an elbow, that means it's starting showing quite a little bit of distance from one point to another. That's why we are looking for the elbow. So if we change from 15 to 30, we are expecting the number of noise to be reduced from the data set from this drawn data set clustering. So if we rerun again, you can see the data set has changed. We have way less noise as when our minimum point was 5. We have now at least one point which is only noise, and then all the other points which are falling in the correct clustering. Are we together there? So this is the same for the next database, which net data set, which is A1, and the next data set, which is yes, this is A1. So this is also forming different clustering, and then from this clustering, we can generate we can generate labeled data set from this. So I think it's enough about DBScan. Let me go to housing and predict so we can be able to. It's because it will be repeating same thing. It will need to be able to tell the epsilon from K graph, and then we need to be able to use the mean point from the rule of thumb. Like if your data set has 2 columns, your minimum point should be 3. But remember, this is the rule of thumb. It's not a rule like you're supposed to follow it always. So basically what it does is you need to try which one work best with your data set that you have. So you shouldn't rely on fixed minimum point or fixed epsilon. You need to understand how we are getting minimum points, how we are getting epsilon, and then from there you can start trying on your data set. So I'll close DBScan and then oops. Okay. Okay. I'll close DBScan. Let me open yeah, let's go with air pollution. So this predicting air pollution, close this, predict air pollution, and then we have CSV. So in this second demo, we'll be using a dataset which is called Beijing air pollution. This is a long time ago dataset where they are from 2010. What basically is here, we'll be having a date. We have pollution day, pollution today. We have dew, we have temperature, we have pressure, we have wind, we have snow, we have rain, and pollution yesterday. So basically what we are trying to do here, we are trying to predict pollution today. That's what we are trying, our target. And pollution today, it's already been labeled like pollution, for example, on 2nd of January 2010, it was this month. So that's what we are trying to predict. But the factors, the features that affect this pollution, it's first pollution yesterday, it's rain, it's snow, it's wind. All these are the one which are affecting these targets, which will be pollution today. Now let's go to the actual coding. So basically what we are, also I should say something, when you're writing your assignments, please try to include the error handling. Please try to use try and catch, this try and exception, so that you'll be able to know if your code failed at some point, what the actual reason it's making it fail. That's a very important point, because otherwise you'll be go on trying and trying without realizing what is failing. So for the first block, what we are is really trying, we're trying to read the CSV, if it's readable. And then after reading, we need to validate. This is just for validation to see if the dataset, if the CSV dataset is empty or not. And then the target column that we are we are trying to predict, it's already labeled, but we are trying to use machine learning to predict what will be if we use machine learning, and then we give it the requirement, we give it the features that are required, what will be our prediction based on this data as it is. So this is pollution, that's the column, and then we ensure that the data is that column is always there in the data set, because you can make changes to the data set without changing the code. So we are confirming that. And then with the date, we're just breaking up the date into year, month, and day. And then we are getting the week from the date, and then also day of the year. So basically, if we are humans, we are given a file like this, and then we have been told to calculate or to predict. We're told to predict the pollution for today or any other day, and then we have all these other parameters which we have. What we'll be using, there are two methods. Even in the machine learning, those methods are also applied. Either we use regression, or we use something called, let me find it, decision tree regressor. Yes, decision tree regressor. Yes, we will be using either of these two methods to be able to predict just the air pollution. So what is linear regression? After we end up with the code, just reading the code and then getting the pollution today. If we are using linear regression, what basically is happening is basically we are drawing a linear line between the points, so if we have all these points, we'll be drawing it in a 2D linear, whereby we will be drawing that lines to be able to see which points or which features affect the pollution today or affect the pollution in general. And then from those features, we will be able to see from this data set if temperature reach a certain level, how the pollution will be. If the wind speed reach a certain level, how the pollution will be. So for example, especially using wind or snow, if there is a wind which is coming at a particular value, how can we predict how is this factor itself will be affecting the pollution? Wind comes with dust and everything that is in the wind, same as snow, it comes with some of the things which can be able polluting the environment. So with these, all the other factors, which we call features, we'll be using them and then inputting them in the linear regression equation. And then from there, we'll be seeing how they are affecting, or how can we use these data to predict the today or future data. I think I explained the linear regression well. Once we reach the same way let me explain also the decision tree regression, decision tree regressor. This is the machine learning algorithm, and they use predict continuous and numerical value. So basically, itself, it's a machine learning algorithm. It's not a statistical algorithm like linear regression. Basically, what it does, it's arrange the data in form of a tree. After putting them in form of a tree, it will be checking for pollution to happen today, which trees are affecting that particular, or if you see this structure of a tree, it forms with these values, pollution will be happening by this value. That's basically it will be doing. So let's start with linear regression and explain it based on code. So we'll be, we'll be needing to handle something called missing data. If you'll be given a data set like this, I don't think, yes, it has some of the missing data. For example, snow, some days they don't have snow. Rain, some days don't have rain. Wind, there are some days which don't have wind. I don't think so. But basically the thing we need to understand is how to handle missing data, especially when we are doing we are using linear regression and we're trying to handle that. Basically, what we usually do is basically find the median. Median is the middle point from all the data. If you have your data set and it contains columns, we'll find median from this wind speed. We'll find the median wind speed. So if we have any row which is having null data, what we'll be doing, we'll be replacing that empty row with the median of that column. Hope I put that myself clear. And then, so all that will be handling the missing data and pre-processing the data. So all the values are there. And then we'll have to encode the categorical values if they exist. Now we are in data, we were supposed to also talk about categorical and non-categorical values. Anyway, let's go on. So from there, once we already pre-process our data, we don't have, we already encoded categorical values. They're all numbers. When we say categorical values, values which are, I don't want to say exactly in words, but they are put in a categorical. They are not in actual values. So we'll need to encode them so that we can be able to use them easily in linear regression. There is a way of doing linear regression in the categorical values, but it tends to be a little bit more difficult. That's why we usually end up converting the data to, we'll be encoding it to categorical variables. We'll be encoding the data so that we can be able to use it. And then from there, we'll have our data ready, and our data will be in which variable? Wait. Okay. Ensure data. Okay. The pollution will be holded. It will be the target variable of each. Okay. The X value, this X will be having the columns, all other columns apart from pollution today, which we'll be trying to predict. And then the Y value, it will be the our value that we are trying to predict. So what basically using linear regression, we are getting all the other columns from X, which are in X. We are trying to use them as feature data to predict Y, which is pollution today. So in this X and Y, we try to, we fill the missing data. From fill the missing data, our actual data, which now will be holded in X and Y as in these two lines, whereby X will be holding all the other feature data, Y will be holding the will be having the target column or target value. So next, we'll need to be splitting our data set in folds. We'll need to be splitting it in training and testing data. Most commonly, you'll see the training data is 80% and then testing is on 20%. After we have done this training and testing and we get the accuracy, later on, you're supposed to go do inferencing, that you're supposed to introduce new data, new pollution data to see if your model will be able to detect new data. That's all the goal of trying to mimic, because humans will be able to calculate the linear regression on the other side, but the model will be trained, will be split into training and testing, and will remember based on this, on its training, will be able to predict the new test and will be able to predict the unseen data. So what it will be done on training is basically this 80% of the data of these CSV data will be used in the training. And then the testing set won't be introduced in the model until when we want to test it. So basically, this is the function for linear regression training. That's why the method is written training. So we'll be passing the X and Y. And then once passing them, and then later on, we have a method for linear predict. We now have the X, which is holding the X and the weight, which is, we have the weights, and then we have the new X, which we are we're about to predict. So basically, this function will be taking the data set, the 20% of the data set. Based on the weight, it will be predicting what will be the weather if the features which are given are of this X here. Okay, change it. So later on, it will be train and predict. It will be passed. We'll be calling those functions which we are defined up top. And then by training, we'll be calling these when we split the data. The X train contain the feature engineering, the data contain the features which are about to train, and Y will be having the target that we are about to train. And then later on, we'll have the predict. So after training, we'll be having this weight linear. That weight linear, that when we'll be passing it to the linear predict, whereby we'll be giving it the new test that we want to give it as test, but the weight to predict, to use linear predict will be from the training that we just had. So basically, these two lines here, these lines here in the try and the exception or try and catch are the one which will be taking the knowledge from the training which was done and then applying the new features and seeing how this new feature will be able to be used in the predicting the new data which the model did not see. So one thing I skipped, this linear regression train basically is using the linear regression formulas. So that's why at some point we were supposed to cover these actual formula, what's happening inside linear regression, all the transposing, all those formulas will be passed. So what in the code, what is done is applying those formula, and then we're just saying linear regression directly. But what is done is actually linear regression, the actual calculation, the actual algorithm of performing linear regression is being done here. So after we train, we can then predict, right? So there's one thing I need to say, the train and predict, we need to include these two things, mean absolute error and mean squared error and R2 score. These are metrics which can be used to check how much is our training and testing. We will be validating how much is our linear regression performing once it was given new data. This prediction, how much is it performing based on the 20% of data which was given. So, okay, let me skip this decision tree regress for now. Let me go to the actual, okay, this decision tree. I need to, yes, mean absolute. I need to evaluate both models. So we need to check, to calculate, we need to evaluate them using all the data which are there in the data set. We'll be calculating this called, one moment, which is called mean absolute error and mean squared error and R2, this R2, what is it called again? One moment, it's R2 score. So from these three, we'll be able to tell how is the model performing because it's labeled, so it will be able to check against those and see how much it's performing. So let me explain decision tree regressor, and then we can move to the results. So decision tree regressor is basically, we say this is a machine learning algorithm. It's use decision tree. It's use a tree to be able to tell or to be able to predict the pollution. So it will be having all these parameters, especially maximum depth, we need to define it, and the minimum sample split. So we'll be able to we are forming a tree. Yes, we are building a tree. So from this building a tree, that's when we will be able to tell from those leaves of the tree, the node of the trees, we'll be able to tell how much, we'll be able to predict the pollution based on that. let me skip it for now. Let me go down. Okay. Let me skip the decision tree first. I'll explain it using the linear regression so we can understand the machine learning part of it. So with linear regression, we already seen the training, and then we already seen uh, the testing. So using these mean absolute error and mean squared error and R2, well, it's R2 score. From these errors, we'll be able to tell how linear regression perform. And then for nonlinear regression, which is we use the decision tree regressor, we'll also apply the mean absolute error and the MSE to be able to detect how much did it perform. So based on these parameters, which will be checking the model performance against actual value which are there in the data set, we can see like linear regression will provide more accurate prediction on average, which it has lower mean absolute value. If it's lower, that means it's performed better. Linear regression minimize prediction error. That means it has better mean uh, square squared error. And then linear regression explain more variance in the target variable. That means it has higher R2 or R square value. So from this, that means we are able to, if we have a data set like this, we choose pollution today as our target. And then these all other values, we are using them as features toward predicting this value. So with humans, we can be able to do that once we have all the other how do we say, other features. So if you want to predict the pollution for let's say for Wednesday or for the next Wednesday, that means we will need to have, using linear regression, we will need to have all these previous parameters. And then from these, using these previous parameters, we'll be able to tell how much the future day pollution will be if if using the previous features. But for the example we just did, this is it was given the pollution, it was actually there. So basically, we just used linear regression explaining the pollution today will be with particular number, particular value, based on the features that were given, were seen, or were given up to now. So that is using linear regression and decision tree regressor. I'll add one more example and then we will wind up. We'll see prediction of house prices. So let's see the house price data set. The data set, it has all those location data. It has the house age, how old is the house, housing median age, it has total rooms, it has total bedrooms. All these are just factors which will need to predict. We'll see the column, we'll see the target variable is mean. We are trying to predict the house price. So we'll need to be able to we need to be able to separate the median house value. Where is that median income, okay, median house value? This one. This will be the column, which will be our target value, which will be our target column. All other columns will be used as features or as columns or as attributes, which will be trying to predict, use this median value. Again, from predicting house prices, we'll be needing we can use linear regression or we can use decision tree regressor. And the the measuring those my MSE, the mean absolute error, the mean squared error, and R square score, they can all be used to determine how much our model performs. So as usual, we'll need to load and process the data. It's on CSV. Okay, let's try to do it but these value are in latitude and longitude. So for human, it would be difficult to process them out of blue. But if we were to predict the house value based on these parameters, yes, we can use population. We are living. Mostly house prices will be based on these parameters. How many bedroom does it have? What is the population, household, the median income? All these values, everyone will be wanting to live, will be the price value will be based on this. So if you want to go rent a room or rent a house with a place where it has a good location. Let's say it's close to the sea, it has a small population, the household is good, all that. Even we will be able to know that the price will be higher in those areas more than the other areas where the the columns. Where the population is high, the pricing will be also high. Where the population is low, but it's close to the strategic areas like ocean, given these location data, the price will also be high based on those locations. So it's either way. So basically, again, we'll be using linear regression, where basically what we will be checking is to see if we draw a linear line between these points, between these data, how much of the points will be affecting the price, which was already given as a target column. So I'm repeating all the thing. We'll be loading the data as CSV. This is a function. So it will be getting the file path, which is CSV housing. And then we'll check the required column and ocean proximity if they're there. And then we'll separate the feature data and target. So X, as usual, it will be having the feature. And then Y, it will be having the target data, which is median house value. And then from all this, we'll split it into uh, uh, 80 to 20. As you can see, test size is 0.2. So it's 0.2 out of the entire data set. And then from there, after we split it into training set and testing set, we'll apply linear regression. Is this using? Yes, it's using linear regression. So we'll use linear regression using normal equation. So basically, it's the same as the one which was used in air pollution. So what it does exactly, it will be drawing some points and then drawing a linear line, and then how to see all these we call feature values or features data. X, how does it affect Y, which is the actual price. So by checking if the house is located at a particular area, particular location, and then that is close to the ocean and all that, we will be able to predict the new. So when we do linear regression, let me show the two lines which we'll be calling predict and training. Okay. Simple decision regression tree. It's called in below. Decision tree predicts. This is still decision tree. Plotting results. Okay, we need to see where is. Okay, it's called in main. Okay. So linear regression. We call that class, and then as usual, we separated our data set into training and the one which will be having the target. And then this train will be giving us the weight. From this weight, we'll be using the weight to test or to predict the new data that the model has not seen. That will be passing the X test, will be passing the weight, and then we'll be having the Y predict. That means we'll be having the median value of house, which will be holded in this. And then evaluate, we'll need to evaluate the mean absolute error and then mean square root error and the I think yes and R2 R squared score. So same way, we'll have these values here. We said lower mean absolute error, that means it will be good. lower mean squared error, it will be more good. So linear regression is performed better than non-linear, which is decision tree. And then linear regression explain more variance in target variable, which it has higher R squared. So basically, from the data, that's when we are using these weights, which we trained, and the model understood, like, if I have these, if I have these features, if I have these, yes, if I have these features, how should the prices be? So basically, what it does is, if we're having particular features, how we'll be able to train how we'll be able to predict something new that the model has not seen. So any question up to now with these demos which I've just shown? Any question?
Sir, what are weights?
Weights, how to put it well? When we train, we will be having, let's go to train first. Train, linear, predict, linear, train, predict, build tree, fit in it. This was regression train. What we are training, we will be having values whereby those values, if they reach a particular number, we will be terming them. If they reach a particular number, something will happen. Let me show the definition of linear regression, and then we'll come back to it. Linear regression, just the definition from Google, it's a model that checks the relationship between dependent variable and one independent variable by fitting linear equation across the observed data. So how does the weight come? We are having several columns inside this data set called housing. And then we are having one column, which is target column. All these other columns will be having an effect, yes, will be having an effect on the target column. So that effect, or that will be impacting the median house value, will be impacting the target column. So that impact will be giving it as weight. After we train the model, it will be saying, if the house is close to the ocean proximity, the median value will be of this value. So each column will be carrying a particular weight. If you combine all these columns toward, like the ocean proximity, it's close to the ocean, the population is low, the bedrooms are in the average number, which is required by most of the families. And then the house is median age is average good. With these, or let's assume I just use all these, only these four features, the house price will either be high or low. So that is the weight that will be using. I think I tried to explain it. Should I try to explain it in a different term?
Okay, sir.
Yeah. Or I can explain it using Beijing air pollution. Based on these, all other factors, for example, if there is no wind, the chances that there will be pollution, they are becoming much, much more slow. If you are having a good winter temperature, the chances of having pollution, they are very, very slow. So all these factors, all these features, they are going towards, they are putting weight toward how the pollution will be. That's why it's putted in a weight. Weight is just a variable. We just put it as weight as we can closely rate it to the features which are affecting the pollution. Any other question? Decision tree regressor, we said, is a type of machine learning. It just check the continuous numerical value. It put it in the decision tree, and then from there we'll be able to make decisions. So, for example, here the all these values, they are given like that. You see, this is from Google, but I'll just skip it since we were done. Any other question? I'll try to express it or to answer it, to respond to it. I'm thinking to end up by
Okay, is there any
this.
questions, guys? Freddy, am I audible?
Yes, I can hear you.
Okay. So thank you so much, Freddy, for the wonderful technical session for AI ML. So guys, please note that by the end of the day, we will sharing the attendance sheet and which we have already taken randomly during the session. So we request everyone to join tomorrow using the full name as the username. All right. So attendance, assignment, and feedback form will be sending via email by the end of the day today. And regarding tomorrow's session, we will start at sharply at 10 a.m. Is it clear, guys? Do you have any queries regarding that?
No, sir.
Okay. So thank you so much. You can leave. Thank you.